Vogels approximation method in transportation model. For understanding Vogels approximation method, we consider the following problem. Solve the following transportation problem, minimize the total cost of transportation. Here, the procedure. First, we have to select the smallest element in each row and next to the smallest in the row. For example, if we are consider the first row that are available with that problem is started with 14, 56, 48 and ended with 27. From this, select the smallest element which is 14. After that, next to the smallest. What is the next to the smallest value, which is 27? Okay, from we have to find the difference between both the thing 27 and 14, so that we can get the different as like 13, so that this is penalty. Okay, we can write that right hand side of row, we can call this as a penalty. This is the penalty written on the right hand side of each row. Repeat the same for each column. This is penalty is written below each column. So here also you consider the 14 is the smallest. Next to that 14, the smallest value is 82. So the difference between 82 and 14 is 68. Likewise, you calculate for all the rows and all the columns, other rows and other columns, we can get the penalty as like for second row there is 14, which is the difference between 21 and 35, and for third row there is penalty as 32, which is the difference between the smallest element is 31, the next smallest is 63, so that the difference between both the thing is 32. Similarly, in column wise, the smallest element is 31, the next smallest is 35, so that we can write as the penalty 4, and then third column there is 21 available, the difference between 21 and 48 is 27, so according to third column the penalty is 27, and for fourth column there is the smallest element 27, next to that smallest element is 63, so the difference between both the thing is 36, so the penalty of this fourth column is known as 36. Likewise, we may write the penalty for each row and each column. What is the next step? We have to have select the largest penalty that are available with the row and column. What is the largest penalty? For according to the first penalty identification, there is in row there is 13, 14, 32 available. In column wise there is 68, 4, 27 and 36 available. Compared all the elements, 68 is the largest penalty. So that we have to have introduce or allocate maximum feasible amount to the smallest cost that is available with that corresponding cell or column. According to this, the 68 is the largest, the corresponding smallest element is 14. So I can allocate the feasible amount here according to 14. So here the supply is 70 and demand also 70, so that I allocate the 70 in the smallest element that is available with the largest penalty column. So after 70, what is supply? 70 is cancelled because I allocated with that cell, so that 70 is converted it into 0. After that, in column wise also the 70 is cancelled and I assign 0 because I utilized 70 in the transportation table. After that, what can we do? We perform the same thing. What are the remaining available? The 35, 21, 81, 31, 71, 63 or row wise available. Here also I have to find the difference between smallest element and the next. From this I can find the second penalty for row wise. I can write on right hand side of the row here 35, the difference between 35 and 21 is 14, and the difference between 31 and 63 is the 32. Likewise, I can write the same thing. I can perform with the column wise. I neglect where I got the supply as 0, demand as 0, so that this demand and supply exhausted, so that I leave the column and row for corresponding first. Here the difference between 31 35 4 and 21 71 is 50 and 81 63 is 18. Likewise, I got the penalty in column wise. Here also I compared all the things. The 50 is the maximum penalty, so that the corresponding column I allocate the feasible amount here. Here according to 45 and 47 is available. The smallest is 45, so that I can allocate the 45 the where the smallest element available with that transportation table, so that I can allocate 45 with the smallest element. With the largest penalty is 50 available with that column. Likewise, I can allocate the amount, feasible amount here. Here you see the 47, I can subtract the 47 with the 45, I can get 2, and then here column wise 45 in demand also available, so that I can neglect the 45, I can subtract the 45 with the 45, I can get 0. So here also I can perform another calculate difference, the smallest other thing. In other thing 35 81 available. The difference between 35 and 81 is 46. So row wise I can write the penalty as 46. After that 31 63, here also 32 is the penalty in row wise. After that 31 and 35 is 18. Likewise, I can write here, I compare all the things. Here 46 is the largest penalty, so that I can allocate the maximum feasible amount, which is 2 in that smallest element. I compare 81 and 35, so that I allocate 2 here. So and then I allocate 33 here, so that I can get 33, because I can here have only 2, and then I can subtract here 35 with the 2, I can get the 33, so that I can allocate the feasible amount 33 here, the smallest element. Likewise, I can perform again and again. I can get the corresponding values with respect to all the elements available with the column and row. From this I can get the allocation of feasible amount in respective places. After that, remove all fully allocated rows or columns from further considerations, then proceed with the remaining produced matrix. Here all the columns and rows are exhausted, because we are allocate all the elements feasible amount into the transportation table. So from this I can get the transportation cost of all the things. Here I remove all fully allocated columns and rows from the transportation table. Finally, I can get the values that are available with the transportation model table by Vogels approximation method. In first 70 into 14, 2 into 35, 45 into 21, 33 into 31, 60 into 63, so that finally I can get to rupees 6,798 as the transportation cost. Likewise, we can calculate the transportation cost with the aid of Vogels approximation method. In previous videos, we discussed about the northwest corner rule method, least cost method, and now Vogels approximation method. From this, we can get the lowest transportation cost value. If we are compare NWC, which means northwest corner method, and then least cost method, Vogels approximation method, which method can give the lowest value of transportation cost. From this we can identify the lowest cost, which method is suitable for our manufacturing problem. Likewise, we can allocate the resources into the transportation model table, and we can get the minimized cost transportation value. Thank you all.